Hey guys, welcome to another Workflow Wednesday. I know this is a little bit last minute and impromptu. However, as always, we are bringing you guys live content with none other than your host, Fusion Phil himself over here at JitCAD Cam. Furka, I love to see you out in chat. Bogdan, you guys are on top of it. I just started this thing. I put it together last minute. Looks like I'm a little loud in my microphone. Let's get turned down. Get the microphone a little bit away from my face. You guys can see me. You guys can hear me. Yeah, Stuart, it is a late one. However, I have been getting this question a lot about adding fourth and fifth axis to like a vertical mill if you guys have it in Machine Sim. So that's what we're going to do today. I thought I had content on this. I have content on how to build a Machine Sim, how to go in, how to do fourth and fifth axis work, but I never actually did a video on how to add a fourth axis. So let's go ahead and jump over and kick this thing off. So first and foremost, if you haven't seen my other content, there is another video out there on how to build a machine from scratch. Now, that is not going to be in this video. What I'm going to show you guys in this case is how to possibly go out and take an already built machine. For example, here, I'm going to go to the Fusion library, and we get this a lot. Let's say you're looking at a VF2 here. As you guys can see, VF2 machines, there is some already built. Again, the concept of this video for you guys, let's say, for example, I got this request. We have a VF2. However, we're not going to use the TRT system. We're going to use, in this case, the TRT 160. Again, there's ways to compensate and change this out. What I want to do is just show you guys the way to add that in. Let's go ahead and see on the VF3 level, palette changers. Here we go. So you have a TR system right here. However, it is not a TRT system in Haas's world. So we're going to go back and we're going to actually copy our machine out of our library. Now, where you post this, as you guys know, you're going to post it wherever you plan to store this. I highly recommend using the cloud. If your cloud is not turned on, you can actually change that up in your preferences. So we're going to copy and paste. Again, very easy to steal a machine that works out of the box. As you guys can see, again, we're going to place this machine model. Now, this is important. I would recommend to most of you out there that you go ahead and create a project or store these in a folder all together. Again, making your life easy. I'm going to leave mine right here in the mastering fourth and fifth axis machining. And just like that, we're going to go ahead and have that pasted over. Again, we're going to wait for this has to download the model from Autodesk. Again, it's a Haas machine. If you're going to use that install machine connector, maybe one of these days I'll make a video about that. But as you guys can see, I now have my machine. It is stored wherever I plan to put it, and it would still be a 3-axis machine. Now, we're going to go ahead and shift gears here. I see a ton of you guys out here throwing it up in chat. Love to see you. Stuart, seeing how to set up your rotary winding up to 60,000 degrees. We could go ahead and definitely show you that here in a moment. But as you guys are going to see, I'm going to close this out because this is going to be kind of a two-part scenario. We are taking a 3-axis machine and we are going to convert it to 4 or 5. So I've already downloaded 2 different versions of this rotary. Again, I've gotten these from Autodesk, or not Autodesk, but Haas's website to make my life easy. But as you guys can see, there's a couple of different ways you're going to see this. Now, one, sorry guys, my mustache growing back in is a little itchy, but there is an XT versus a step file version here. Now, this is up to you which one you choose. As you can see, one is a little bit simpler at the assembly level. As you're seeing, they have reduced this down. Now, one thing to pay attention to is on some of these, you may have 2 different rotary platters, right? So again, you have a smaller platter versus a larger platter, and we're going to get into this, but the idea is still the same as when you built out your machine, is the ability to create the groups based on the axes. Now, this is a 5-axis trunnion, so we are going to label these as needed. So this is going to be my A axis. My next one, this is actually going to be the base, or I would say this is going to be a part of my X axis group. And then again, depending on what platter you're using here, I'm going to go with the bigger one in this case. This is going to be my C axis. Now, a really neat thing inside of Fusion that I think a lot of people don't know about is you could have both of these in here and utilize whatever one you need based on your situation. Now, what I'm going to do, though, to make my life easy is I'm going to right click on that guy and I'm going to remove it. And as you can see, it actually has put a mark in my timeline and has completely removed that from this file. So again, as you guys may or may not know, you could hit save here. I'm going to go ahead and just save as. And what I'm going to set this up to be is this is going to be my TRT 160 for Machine Sim. Now, I did forget one other step that is going to be very important here in a minute. We are dealing with a component structure. Now, you could rigid group these in this file, or we could rigid group them. And for those of you that don't know, the whole idea of a rigid group, as you can see, I can pull this file apart, pretty dangerous. So we are going to rigid group this in order to make it so that it doesn't move at all. So again, assemble, rigid group, we're grabbing all three. And now if we turned on our origin and accidentally moved, the entire assembly moves from the origin. We don't need to anchor this to the origin right now. So let's get that origin turned off. We're going to hit save again, and then we're going to edit our machine model. Now, this is where you're going to need to know where that model is residing, because this is going to make it very easy for you to, again, stack up your assembly. Now, again, guys, I have content on this. It's a pet peeve of mine on Autodesk side. I get the enclosure looks cool, but what you're seeing me do is turn on my parametric design so I get my timeline down here. And then that will allow me to do my favorite thing, which is either turn off the static parts, or another thing you could do is keep like the column and everything and maybe just remove the machine body itself. So again, right click, remove. We really don't need the logo and everything out front. So I'm going to do a secondary remove. And now my static, AKA my base, is all under one area and there's no machine enclosure in my way. So let's go ahead and let's bring in now our TRT 160 for Machine Sim. Now, when we go to place this on our machine, again, as you guys can do, I like to move mine around a little bit. And that way I can get it roughly in the right orientation. Now we are going to place this on the table, of course, but I just want to point that out to you guys that it's nice to just get Z-axis pointed up. So when we do a joint here in a minute, we can work both ways. Now I do want to break this link. Again, we want to bring this into the assembly to be rinsed and repeated. And then we're going to make sure later, and you guys will see this, that we are selecting with both our X-axis and we're pulling that base of the trunnion when we do our machine definition. So let's go ahead and throw our joints on here. So I'm going to go ahead and do a joint. I'm going to grab either bottom center, or this is where the value of something like between two faces can be very beneficial. So again, I have face 1, face 2, and then I could define my snap point. Oh, we're getting a little too far in there by holding control on the surface and then getting to this far out corner. Now that is created, again, between two surfaces and then center of those two surfaces. And I can rinse and repeat the same thing. Coming down to my table, surface 1, surface 2. And then the snap point I'm going to use here is going to be, again, top left corner. And as you can see, that rotary has now snapped down onto the table. I did accidentally pull the inner T-slot versus the outer. And you guys can go back and adjust that. But really, what I'm looking to do is just slide this guy over so that it sits basically center on my table. Now, if you're going to be nitty gritty about this at the end of the day, you could do a lot more to get it perfectly where it is based on your machine. As some of you guys know, you may actually mount it closer, further away, and we could play the game of limiting our travels so that you could swing those bigger parts and not do a whole A360. But I want you guys to pay attention here, because as you can see, although we did do a rigid group, the rest of my rotary is still over here on the left, but that's okay because Fusion is just showing us me moving the base onto the table, and upon hitting OK, everything else has moved with it. So as you guys can see, we have our rotary on the table. We also have our machine still defined, and we're cheating here because we stole one of Autodesk's pre-builds. Again, I got that video content for you guys to go out and build your own machine if you have a solid model, or as always, guys, you can enlist the help of yours truly to help you with this. Now, one thing I personally do, and this might be me, now you guys can tell me whether or not it's beneficial, is depending on if you have tilted plane dynamic work offset G68.2. This is where I might, at the end of the day, create a joint origin. And the nice thing about the joint origin, as you guys could see, is I could put one down center on my platter. This might be my fixture location. Again, I'm going to flip it up and then utilizing my color coding, make sure that we're orientated correctly. Now, the other joint origin option that I could place is from my center of rotations. Now, again, it's up in the air which way you guys go about this. If you know it is a specific distance off center of your platter, as you guys are seeing me do here, let's say, for example, we're going to eyeball this. Let's say it is roughly 30 millimeters up to center line of my A from center line of my C. Again, the idea here is to make it very easy. If you're going to use center of rotation, you could just click this joint at the end of the day. Or if you have dynamic work offset, cycle 800, there's a million different versions of it. You could go right off of your table. Now, this is optional, just like removing the enclosure. But as you guys can see, we now have the rotary on the machine. We're going to go ahead and save the machine itself. And then we are going to go change now everything in Machine Builder. So sometimes you get the error, sometimes you don't. I've always found it's easiest to jump to a blank file here. As you guys are going to see, we're going to jump over to manufacture. I'm going to go ahead and go all the way over to my machine library. And then again, tracking down that machine because we are going to go ahead and right click. And it's going to allow us to edit in Machine Builder. Now, this is where we need to do quite a few things. But as you guys can see right out the hole, if you're not familiar with the linked system or file updating, is we get this error. Now, as you can see, although we've been manipulating this machine, I'm missing my rotary, and we still got that dang enclosure in the way. So what I'm going to do is I'm going to go ahead and click my Get Latest Version. It is now brought through that entire machine sim model. Again, removing the enclosure and adding my rotary. So that was step one. Step two, if we work through our design tree or our process up here in our toolbar, is I'm going to go ahead and say Edit Machine Definition. Obviously, we need to let the guys know on the floor that this does have a TRT 160 now, right? We're also going to want to go down to our kinematics tree, and we're going to have to update our kinematics. Now, it is very important for a lot of you out there to pay attention to your kinematics tree, because if you had a head 5-axis, we would need to actually add our rotaries to the Z. In this case, ours is a table 5-axis. So I'm going to go down to the A, and I'm going to click, or X-axis, I should say, and then I'm going to click the plus sign because we want to add a rotary axis. Now, by default, this is A. If your machine is a B-axis, C-axis, or BC, or an AC, you're going to be able to define those and change those out. I'm going to go ahead and add another rotary axis. And as you guys can see, my A axis, again, labeled as A, is from coordinates. Now, what does from coordinates mean? Well, again, based on my world coordinates, A axis is going to spin around that X axis. Now, if you have to reverse this because you mounted your rotary backwards, it's very easy to flip direction. And as you guys can see, again, we can override whatever we're doing. Now, again, this is where Fusion has made some different changes. As you guys can see up here in my toolbar, I do have the ability to redefine the planes, but we're going to just go back to from coordinates. Now, somebody asked the question about limiting the 60,000 degree move. Now, on the A axis, again, this is where we get into a range. Now, you do have what's called limited. If I was to move that rotary further forward or further back, or try to swing a very large part, I may limit my rotary to -90, +90. So now I can only go from like a 3 o'clock to a 9 o'clock position and never go past that. Now, I could also go unlimited. With most A axes, you can go unlimited, or you can go cyclitic. Now, what cyclitic is going to do is output basically multiples of 360 in this case. So again, 0 to 360, if you go past 360, it would climb back to 1 and continue onwards. So in this case, ours is going to just basically be unlimited. Now, I do want to warn you guys, because this is where I've had a couple of customers reach out where in the case of your machine, it may make contact, as you guys are seeing here, with things on your table. So this would be wise to update. Now keep in mind, we need to tell it our our A axis has to be aware of the head, the Z, and the tool. Now, is your A axis possibly going to collide with stock, table, and anything else? No, because they're all sitting on top of there. So if we go to C axis now with the same concept, we're going to go ahead and do unlimited. Again, we're going to verify that we are worried about head items. So the C axis is getting checked against the head items. But lastly, what I want to do is I want to jump back up to the top and go to my Z axis. Remember, we have added additional items in. So we just want to make sure that the Z axis, again, we don't want the Z to hit these items. The head itself, if we are utilizing a head, we want to make sure the head isn't hitting these items. Again, guys, this is why we offer support packages to help you guys build this out to your spec and get it all set up. Now, again, here's another pro tip for you guys. Based on your spindle RPM, again, let's say you have a 12K machine, we can update that information in real time. We can also set our coolant options for that machine as well. Jumping from machine to machine, as you guys know, some have through coolant, some of your machines might not. Fusion will tell you if you have a tool with through coolant that it cannot be used on that machine or an RPM exceeding. So I'm going to touch on one more thing here real quick. I did gloss over this. I apologize. Our A and C axis, you want to make sure that if you do have TCP, you're going ahead and enabling that option based on what you're doing. Again, the idea here is at a high level, guys, we're just adding a rotary to an already confined machine. So we can move down. You guys have your post processors, of course. We also, in our multi-axis situation, this is one of those things, as somebody was asking about winding the machine up, you may want to enable retract and reconfigure. Again, this allows the rewind, unwinding of the rotary axis. Again, a lot of machines have different ways. If you're doing 5-axis, it's the pickup, spin around, and reposition. Another pro tip I'm throwing in here, I get this question all the time. Depending on your machine, you do have the ability to swap out to things like inverse, degrees plus combination. This is how we're commanding the rotary to move. If it seems like your rotary is moving extremely slow, it's probably because your controller can't use program feed rate. We need to see feed rates, you know, like 300, 3,000, 30,000 degrees per minute, right? So as you guys can see, I went ahead and I've edited everything out. So what I'm going to do is I'm going to go ahead and hit OK. Now we can move through the process. We don't need to move our components. We've actually placed all of our components exactly where they are. It is very wise to have your model represent the home position of your machine or where you plan to do a lot of your base things from. In this case, we're top center of the table over top of our rotary. So I can now set up my machine model. So what you guys are going to see me do now is this is where we need to redefine where our part is, because originally, remember, our part was probably on our table. So this is where I use those joint origins to my advantage. I may want to either go off my platter or I want to go off of that center of rotation. Again, the joint origin trick is going to save you guys a ton in a 3-axis or a 3-axis with a 4th axis on the side over here. You could put a joint origin on the table for your, can't talk. You could put a joint origin over here on the left, putting your Kurt vise, and then you could have a joint origin over on the right for your rotary, right? So again, very nice when it comes to actually adding your parts in here and setting things up. I'm going to go ahead and define mine right off of the table. We're going to move down a little bit further. Now you do have your static part. Again, we did do some reconfiguring in this model. We're going to go back. We're going to add our static component in. We have our Z-axis. Our Z-axis, nothing has changed. We could go down a little bit further. Now, some of you are going to notice there is a head option. You guys can use this option. I've found that it's easier just to leave it out right now, but we're just going to continue down that list. Again, we lost our Y-axis. So let's go ahead and find our Y-axis. We're going to go to our X-axis and reminders. I can't stress this enough, guys. I've said it multiple times. This is where we actually need to add 2 options because we need the table and the base of the rotary. So again, I'm not clicking the entire assembly of the rotary. I'm just grabbing the base component as well as the component for my table. Again, we move down a little bit further. We grab our A axis. We go a little bit further and we grab our C axis. Me personally, I like to grab all of my items first before I go back and worry about secondary things. For example, we need to set the A axis rotation. Well, I'm going to get lucky on this part because there is this nice round surface here. However, if you did want to, you could turn the A axis off and you could use something round on your model, right? So again, I'm assuming I'm pretty good at these guesses. A axis is going to rotate around that radius or diameter. Now, again, we can rinse and repeat. We go to C axis. I'm going to go ahead and turn my C axis off. Again, guys, you can utilize edges on your part to your advantage. Maybe your platter spins off center. You never know. So as you guys can see, I'm going in. I've now defined everything. And I'm going to pause for a brief moment because I see Stuart out there. How do you define A0 in a program? Is that from the Z direction or from the first called up toolpath? So your A0 is going to be based on the direction that your Z axis is pointing. Now your A0 in your program is different than your work offset A0. And I say that because when you do your part probing or you pick up your XYZ location, you can compensate the controller to get everything flat, parallel, and square to the machine. So let's go ahead and now let's test everything here. So if I jump over one more, we have preview machine movements. Now, as you guys can see, my tool up here at the top is already jumped into the spindle. So if I go ahead and bring my Z axis down, we can of course slam it into the table, right? Love to crash that machine. But one nice thing about this, as you guys are seeing, is I can see in real time that that tool, when it hits my rotary platter or it hits my table, it is causing a collision. So this is, again, a good way for you guys to test these out. Now, my tool and my C axis are not causing a collision. I can fix that in my kinematics tree, but let's test everything else, right? Little shake and bake on the Y axis. Y goes in and out. Our X still goes left and right as needed. Our A now tilts. Now, this is key element. If you guys start to tilt your A axis and it's swinging, and I say swing like a playground swing, it's because you failed to define the rotation properly when we did our actual setup machine model. So lastly, we're going to go ahead and do our C axis. Again, as you guys can see, that C axis rotates around. Yes, the joint origin are spinning with it because the joint origin is connected to it. However, that's not going to affect anything later when you use it. So let's go ahead and make that kinematics change real quick. So we're going to go in and edit our kinematics tree. We're going to jump down to our kinematics C axis, and let's just make sure that our collision between our tool and our machine is correct. It is, which means I think we're just having a little bit of a graphics problem here. Again, if we want to verify that one more time, we have our Z axis, Z with C, and then the head itself. Let's go ahead and check our tool, table, other items, AC. Looks like everything is checked to be able to verify that. So I think on my side, we're just so close to the edge, but just like that, you guys have seen how we've defined this and set it up. I'm going to go ahead and finish my machine builder. And lastly, we're going to go ahead and jump in and just throw in a cube real quick and test everything out. So one more time, I have that blank file open. I'm just going to simply design nothing more than a rectangular part. You guys are going to see me do this kind of quick. We're going to throw a circle in here. Let's extrude that out. And then for the sake of programming, let's just go ahead and throw another circle over here on this side. And that'll just give us a couple of features to work with, right? So jumping into the manufacturer side of Fusion, we could create our setup as you guys know. Again, somebody was asking about the A0 location. Again, with Z vertical, A is based on X. If you're on a horizontal, it'd be easier to flip down this way to understand. Z comes in and you rotate around Y. Now, as you guys can see, I'm going to go off top center of my part. I'm going to go ahead and select my machine in this case. It's going to take a second to come through, which is a perfect opportunity for me to hit you guys with the old how to support this channel. Of course, you guys know, let's go ahead and hit the like, subscribe button. Leave a comment down below if you guys are liking what you're seeing as well. If you've learned something new and I've made your life much easier, feel free to buy us some late steaks, lobster as well. We also have beer on the menu like always. So I'm going to go ahead and switch back here. As you guys can see, I have this guy set up. I've selected my machine. I've now gotten my part position in play. And if I was to scroll down here, as you guys know, is if you had your fixture, you would define your fixture. But we're going to go ahead and just jump straight over to part position. Now, as you guys can see, by default, it has placed my part at the part location based on what we built in the machine definition and our machine sim build, which just so happens to be my joint origin down there on the table. Remember, we said part here. If we said part up above, we could have used that as well. Now, on the fly, you guys might have to do some things or want to switch out your positions. This is why I was telling you about using joint origins for locations on your table, maybe on a tombstone, because I could always use a selected point, and then that selected point is going to be based on a model location. So let's say, for example, I'm going to go center of that actual bore, and I want to be referenced based on this additional joint origin. So again, you guys can now compensate, of course, move your part wherever you need it out in space, wherever that part is going to fall and be located, right? Now, from here, we can go ahead and hit our OK button. We're going to go in and create a couple of toolpaths. I'm going to face this guy off with the good old trusty 1/2" end mill. No, we're going to go 2" face mill here. And then I'm going to duplicate that using Control D as in Delta. Just allows me to create another version of that. Again, we do our tool orientation down to this side now. Again, facing off the side of our part. And this will give us something very simple to go in and actually simulate with machine and do all our check and balances of whether or not this is going to work. Now, I do see Stuart out there with a question. Stuart, on the Haas tools drop down on tool change, when it drops out of the spindle, can you simulate a tool change? You cannot, I believe, as of right now, simulate the physical changer, but we can change your tool change position, right? So I just wanted to show you guys what he's asking about actually goes hand in hand here. As you can see, my tool just jumped into my spindle. We have our facing cycle. We've moved up in Z, and then we've come back over. Again, we could face off the side of our part. So it looks like our machine sim is working quite well. And for you guys out there, we could go ahead and turn on the base again so that we could see that base in real time. But just like that, we've added our 4th and 5th axis, right? But let's take it one step further, as Stuart is calling, is we want to change where we go for tool changes. Now, that is going to be something that when we post-process, we're going to have to edit a post-processor for, which means I can't use the default post-processor. We're going to go ahead and jump into none other than the place where we have tons of post-processors for me to ruin. And as you guys are going to see here, I'm going to go ahead and we should have one right here. Let's go ahead and edit this. And what I'm looking for, simple enough, if you just use a little Control F, as in Fox, we're looking for home, and then you could say XY. So as you guys are seeing in this line, we have home XY. Now on indexing, do you want to go to the home position? On tool change, do you want to go to the home position? Again, this is where we can define the table to go to a location to which we can set an increment for that location. Let me just be clear with you guys. So for example, is maybe I don't want to go on program end, both X and Y axis. I just want to bring the Y axis forward. Or again, I can add in, and there is some samples over here on the left, is we could actually highlight these options. Again, it's easier usually to steal something along the way. Let's say, for example, I'm just going to send it to XY on both, and we're going to plug that in here, there, and everywhere. And I'm going to hit save. Now, I am going to do a file save as here, just so we know what is going to happen. And that way we could select the right post processor. So again, we've saved that all in there. We're going to go ahead and close that window out. I am going to need to reassociate the post processor to the machine. It's not a big deal at the end of the day. You can go in through your setup. Just make sure that when you guys do edit your machine, that you actually make sure the cloud is updated as well. We're going to go post processor, swap this guy out. Again, we're going to go up to the good old trash folder that I never seem to clean out. But here's our Haas Next Generation Home XY. We're selecting that. And now if we go ahead and resimulate with machine, Now, if you're experiencing a lot of problems with machine simulation, slowness, it takes forever to load, I will warn you guys, is I'm going to jump back over to where we opened that other file. Notice how there's a million things in this file, right? There's air hoses, there's nuts, there's bolts. This is where on our end, when you guys have our support packages, is we eliminate as much as we can out of these files to get them to run light, clean, and easy. Again, if you're suffering from performance issues, that isn't because you're using a 6-year-old computer. Odds are your machine sim is too complex built, right? So let's go back over here. I failed to actually stay in that window. I didn't realize when I switched tabs, it would close out my machine sim. But as you guys can see, once again, we have our machine. Let's get orientated the right way. Third time's the charm jumping inside a machine sim. And we can, again, now simulate this part. I'm going to pull up the G-code. Again, up here at the top, guys, you can see your G-code in real time. So as you guys are going to see, we're going to run down this list. Now, one thing that is happening is we are not jumping to a specific home location, right? So as you guys can see, my G53XY0, it's still coming out as 0. As you're going to see, we're going to go back into machine sim one more time. Not machine sim, machine definition, because in our kinematics tree, we are going to need to set that home position as well as tool change position, right? So again, if we were to say -10, again, jumping down to X, let's just say on X, we're also just going to go -10. Again, the idea here is to show you guys what you can do, adding these on as how you could actually utilize this to your advantage. Ash Design, great to see you out there, buddy. Is there a way to force a tool angle while doing a rotary parallel down a part? For instance, we are doing a rotary parallel down a cylinder to just lock the table at an angle. So the question, I guess, would be, Ash, one, that's something I can answer this Friday by all means. But if you're looking to do something in 3-axis only, you need to utilize tool orientation. However, if you're looking to fix a 20-degree angle based on that tool against the surface, that's something where we're going to need to look at some other toolpath. So again, let's get our G-code popped up here. As you guys can see, the very first thing we have is our XY position. Now you're noticing my tool and my machine is sitting over here to the left. Again, this is where we could have added a Z home position. And for most of you with those Haas machines or old Fadals, you get about 4 inches of extra Z travel above 0. We could have also incorporated that in. So let's go ahead and hit play. As you guys can see, that was very quick. We have now jumped down. We've faced off our part. And as I click and drag on my screen, we go back to our home position. We're now tilting and coming back over to continuously machine our part. Now, again, we could handle this in the machine sim, as you guys can see. On a lot of controllers, you can actually define that at the controller. So, any issues with GPU simulation crashing Fusion? Well, I would say I have not, but some people have reached out and said that they have had GPU crashing. Now, I am going to show this to you guys. Again, the idea of this class, if you're here to learn how to put a rotary on your machine, obviously this is a long video. You guys can also reach out to yours truly. We offer these services in a lot of ways. Now, somebody's asking about the GPU crashing. Again, this is the luxury of Fusion, that if you go back to traditional simulation, let's say you just need fast results, you can turn on simulate faster with your GPU. Now, the problem that I've noticed in the trends is under your preferences, right? Is if you go down to your actual graphics driver selected in the software, I've gotten a lot of complaints from people on OpenGL graphics settings. Again, OpenGL tends to be associated with professional level cards. Again, a professional level card, your Quadros, your P2000s, whatever you guys might have, I've seen that there is a trend that there is a problem related between those two. Me personally, I'm using a good old-fashioned gaming computer, gaming graphics card, and I've been never happier with the GPU performance at the end of the day. But as Stuart, if you want to go ahead and send me an email, I'd be happy to jump in and help you out with that in any way, shape, or form. So again, guys, As you know, it's not what you know, it's who you know. You all know Fusion Phil over here at JitCAD Cam, and not that I don't enjoy doing this for a lot of you guys. A lot of you like to learn, and you have the freedom now to watch this video as many times as you want, hopefully a couple of hundred to get the view count up. But you can do this on your end, or you can always reach out to us. Now, if this helps solve any problems you had, you like what you see, don't forget, like, follow, subscribe. If you're watching this at a later date, feel free to leave us a comment down below, but we will see you all on Friday, hopefully with a solution to steward your problem. And to say the least, guys, I'm going to enjoy every one of those beers, steaks, and lobsters that you have been buying to help support this channel. With that, I hope you guys have the great rest of your day.